Mark. This is going to be kinematics graphing. Consider the object that moves at a constant velocity of 5 meters per second for a time period of 5 seconds, then accelerates to a final velocity of 15 meters over the next 5 seconds. Such a verbal description of motion can be represented by a velocity time graph, the graph shown in the whiteboard.
The horizontal section of the graph depicts a constant velocity motion consistent with the verbal description. The positively sloped section of the graph depicts a positive acceleration, consistent with the verbal description of an object moving in the positive direction and speeding up 5 meters per second to 15 meters per second. The slope of the line can be computed using the rise over run ratio. Between 5 and 10 seconds, the line rises from 5 meters per second to 15 meters per second and runs from 5 seconds to 10 seconds. This is a total rise of 10 meters per second, the total run of 5 seconds. So the slope rise over run ratio is 10 meters per second over 5 seconds, which is 2 meters per second squared. Using the velocity time graph, the acceleration of the object is determined to 2 miles per meters, 2 meters per second squared. During the last 5 seconds of the object's motion, the displacement of the object can also be determined using the velocity time graph. The area between the line on the graph and the time axis is representative of the displacement. This area assumes that shape of trapezoid, as discussed before, the area of a trapezoid can be equated to the area of a triangle lying on top of the area of a rectangle. This is illustrated in the diagram that will be drawn on the whiteboard.
Now, as you obviously know that the area under the graph equals the amount of distance covered in the velocity time graph, you can split the graph to be in a rectangle and a triangle. So all you have to do is just find the area between each one, which is for a rectangle base times height, and for a triangle base times height times 1/2. So for the rectangle is going to be 10 times 5. So it's going to be 10 seconds long, 5 up. That'll be 50 meters. And for the triangle, it's going to be 5 times 10 times 1/2, which would be 25 meters. The total area of the rectangle plus the triangle is equal to 75 meters. So the displacement of the object is 75 meters during the 10 seconds of motion. Once constructed, the velocity time graph can be used to determine the velocity of the object at any given instant during the 10 seconds of motion. For example, the velocity of the object at 7 seconds can be determined by reading the y-coordinate value at the x-coordinate of 7 seconds. So velocity time graphs can be used to review or determine numerical values and relationships between quantities, displacement, velocity, acceleration, and time for any given motion.